Welcome to chapter 4, which is force system resultant. Yeah, so in this chapter we're going to look at 4.1, which is the moment of force and scalar formulation. Yeah, then we'll be continuing to cross product, moment of forces, vector formulation, and principle of moments. So at the end of the lecture, you should be able to understand and define the moment, determine moment of the force in 2D and 3D cases. So initially we will look at the 2D cases. Yeah, so the application of moment, yeah, there are so many application of moment, because at the end of the day we don't want, in statics, and we want equilibrium to be zero, which means we don't want any movement. Yeah, and so in this case summation of moment will also be zero. So beams are often used to bridge gaps in wall, so we have to know that the effect of the force on the beam will have the support of the beams. Yeah, so like in this case here, this place here is creating a moment. It's like a fulcrum here, so when you pull the side, so it's like going through a rotation. Yeah, that's also moment. This is also moment where we have force, and then we have perpendicular distance to the axis of rotation, so there is also moment. Yeah, so now in the case of 2D, let's look at 2D first. Let's look at 2D. That will be your chapter 4.1 that we're going to discuss now. Yeah, so in 2D cases, the magnitude of moment is force times distance. If you see, even work is force times distance. Moment is also force times distance. Now the distance is varying actually between these two. As for moment, it would be perpendicular distance, and as for work, it is parallel distance. Okay, let me just explain here to you. Now for work, if you, let's say you have a box on a slope, on a what do you call a floor, then you have force, right, being dragged, and this would be the perpendicular, the parallel distance. So force in the direction of distance, so this is work. Whereas for moment, what happens is that you have an axis of rotation, something like you put a thumbtack on a ruler. Okay, something like you put a thumbtack here on a ruler, then you take your hand and you push this. Yeah, you push the ruler upward. So what happens? The ruler finally goes through rotation. So if you see here, this is the force, and this would be the perpendicular distance, because the distance here is actually 90 degrees. So that is the moment. So moment is force times distance, distance that is perpendicular. Okay, giving you unit of Newton meter. So the direction will be either clockwise or counterclockwise. Now remember, moment is actually a vector. Yeah, direction is important besides magnitude. Okay, so for an example, so we have got many examples here. No matter what happens, if let's say this is your axis of rotation, let's say O is your axis of rotation, you have a force up here, right? Yeah, force F up here. So here you can divide them into Fx. So as for Fx, the perpendicular distance will be from here to here. Now as for Fy, now watch Fy, yeah? Okay, Fy is perpendicular because the force is here, right? So the perpendicular distance will be from here to here. So it's like taking a ruler, putting along the Fy line, and then you put another ruler at O, make sure the distance is actually perpendicular to each other. So that would be the distance. Now this is all for 2D. Yeah, this is all for 2D. Let's go into an example. A cross product will be chapter 4.2. We'll go that in the next video, but before that, let's go through an example here. Okay, that I have done here. I've taken out from the textbook. Let's analyze one by one. Okay, we know moment is force times distance. Okay, let's look at the first case here, this one. Okay, what we have here, we have a pin here, let's say a thumbtack or a pin here, and then you have a rod. Yeah, then you have a push down here, which is 100. So what's the distance between this? You place a ruler here, you place a ruler here. What is the distance in between? It is 2 meters. So this is what meant by force times distance. Okay, it will be 200. Now let's see how it goes. Okay, I'm going to erase all this. Let's see the direction, how to know the direction, whether it's clockwise or anti-clockwise. You look at this. This is your pin, and this is the force. The force has to go around the pin. So this would be clockwise, right? Okay, because you know your clock 12, 6, 3, 9. this way is clockwise, yeah, whereas this way is anti-clockwise. So in this direction, can you see this is going this way, so it is clockwise. Okay, so that is very, very important. So this is how you write your answer. So the answer is 200 Newton meter clockwise. Can you see the arrow there? The arrow is very important. Now let's move on to the next question. Okay, the next question, we have B. Okay, let's see, B, 50. Place a ruler here. Okay, and then take another ruler, place it up here. Can you see what is the perpendicular distance between these two? 0.75. So which means 50 times 0.75. Now let's look at the direction. It has to go around the pin. So what will the direction be? Clockwise as well. Yeah, so it is clockwise as well. Can you see that? Okay, let's do example 3. Okay, let's do example 3. So what do we have here? Put a ruler here, 400, and put another ruler here. Okay, what do you have here? 4 plus, okay, this distance, you cannot take 2 meters. Yeah, 2 meters is actually the, what do you call, it's not the flat distance, it's not the distance in x direction. So the distance flat here would be 2 cos 30. So 4 plus 2 cos 30 multiply with 400. Yeah, 4 plus 2 cos 30 multiply with 400. What about the direction? The arrow is actually pointing downward, so it goes this way. Okay, once again it is clockwise. So let me just erase all this to avoid confusion, and we will move on to the next example. So I'm going to move on to the more complicated example below here. Just pay attention. Once you have mastered it, it becomes very easy for you. So 600 is pointing here. Put a ruler. Remember what I told you. Put another ruler at point O. So ruler at point O can be flexible. Yeah, can be flexible. The point O, you first have to place your ruler on the 600. Only then you can place the second ruler, which is up here, the second ruler. Yeah, to follow the first ruler. Both the rulers must be parallel to each other. So what is the distance in between these two? So what is the distance? It is 1 sine 45. So what do? Yeah, you take 1 sine 45, multiply with 600. Now let's see the distance. Let's see the direction. Let's guess the direction. This direction has to go around O. So it always must take the shortcut, the easiest method. Yeah, you shouldn't like force it, like make it difficult for it to make a U-turn. Like for this, it's easier to go this way, right? It's just with a flow. Yeah, with a flow. So this is anti-clockwise. Can you see that? So 600, 1 sine 45 and anti-clockwise. Let's move on to this question here. You have point O. Okay, you have this force here. Put a ruler there. Put a ruler here. The distance between here and here is only 3 meters. It's not 4, yeah, because 4 is from here to here, 4 is this whole thing, and 1 is here, so balance here is 3 meters. So what do we have here? We have 7 multiplied with 3 meters. Now let's look at the direction. The direction can be a bit tricky. Yeah, direction can be a bit tricky. So this is clear. The direction will be, it will push this thing to go around. So push the thing to go around, this will be also once again anti-clockwise, yeah, or counter-clockwise. Okay, look there. Okay, so we are done with the first part of chapter 4. If you're not clear with the direction or whatever, yeah, please do see me during the consultation hours. Please ask me during the consultation hours. Okay, with that, thank you.